Solving systems of linear equations, Part 1. Solve the system by the substitution method. Here we have a system of two linear equations. To use the substitution method, I'm going to take one equation and solve for a variable in terms of the other variable. So we can choose whatever equation we want. I'm going to choose the second equation and I'm going to solve for y. So 2x minus y equals 11. Again, I'm solving for y, so I need to subtract 2x from both sides, and I get negative y equals negative 2x plus 11. Next, I'll divide everything by negative 1. And I have y equals a positive 2x minus 11. So I have y equals an expression with x in it. That means I'm going to take my expression for y and plug it into the top equation. And then I'll have an equation with only x in it so I can solve for x. So I'll take the top equation. You always want to use the other equation that you didn't previously work with. So I have 7x plus 8y, and instead of the 8 times y, I'm going to plug in 2x minus 11, because that's the expression that y equals. Now I have an equation with the variable x, so I'm going to solve for x. The first step is to distribute the 8 to each term in parentheses. So I have 16x minus 88. Next, I'm going to combine like terms on the left side. 7x plus 16x is 23x. Now I'll add 88 to both sides. And I have 23x equals 46. Lastly, we'll divide both sides by 23. And we get x equals 2. Now I want to solve for y because the solution to a system is an xy ordered pair. I found the x, so I'm going to take the value for x and plug it into my second equation to solve for y. My second equation is 2x minus y equals 11, and I'm going to substitute that x equals 2 into the equation, so I get 2 times 2 minus y equals 11. And this is 4 minus y equals 11. So I'll subtract 4 from both sides, and we have negative y equals a positive 7. Now I want to divide both sides by negative 1, and I have a positive y equals negative 7. Now that I have my values for x and y, I can state my solution. And the solution is 2, negative 7. And we're listing this as an ordered pair where x equals 2 and y equals negative 7. So this is my final answer. Solve the system of equations by the addition method. Here I have two linear equations. In order to use the addition method, I want to somehow combine the two equations so that one variable is eliminated. In order to do this, I'm going to multiply the second equation by a negative 3. Because when I multiply the negative 3 to the 3x, I'll get a negative 9x. And then when I combine those equations, the x's will be eliminated. Okay, so I'm going to multiply the second equation by -3. That means I'm going to multiply every term in the equation by a -3. When I do that, I get a -9x minus 6y equals 0, because -3 times 0 is 0. And my top equation stays the same. Now I'm going to add the equations together in order to eliminate the x. So 9x minus 9x is 0. Then a -5y minus 6y is a -11y, and that equals 66. Now I'm going to solve this equation for y. So I'll divide both sides by -11, and I get y equals a -6. Now I want to solve for x, so I'll take either equation and plug in the value for y and solve for x. So I'm going to take the top equation, which is 9x minus 5y, and instead of placing a y, I'm going to place the value for y, which is a -6. And then we'll just solve this equation for x. So I have 9x plus 30 equals 66. I'll subtract 30 on both sides, and we get 9x equals 36, and then divide both sides by 9, and x equals 4. So the solution to the system is 4, -6, and again this is written as an ordered pair.